French Nieuport aircraft are still remembered in Russia. However, this memory goes back to very distant times, to the era of the first flights, fabric-covered wings, and flying furniture. Indeed, the Nieuports appeared in Russia in 1911, when aviation was just beginning to spread its wings. At first, monoplane Nieuports were used, but in the following years, the sesquiplane models became the most popular. Over a period of about 15 years, the French machines were actively employed in military aviation, took part in the First World War and the Civil War, and formed the basis of the Air Fleet when the Red Air Force was created. By 1920, Russian aircraft factories had built more than 1,000 Nieuports of various types, while several hundred more were received from France. Although the sesquiplane models gained the greatest fame, the family actually began with monoplane Nieuports, nicknamed the Nieuport with the spoon. The aircraft received this humorous name because of a distinctive anti-nose-over ski that strongly resembled a tablespoon. The French mechanic Édouard Nieuport, like many of his colleagues at the dawn of the 20th century, first took an interest in cycling, then began experimenting in the field of electrical engineering. From 1908, when Europe was swept by the aeronautical boom, Nieuport, with his characteristic enthusiasm, turned to building airplanes. His first flying machine, designed as a monoplane with a derrick engine producing 18 horsepower, was only an experiment. But his next aircraft, which appeared in 1910, became a major step forward, not only for the designer himself, but for the entire development of aviation. Taking the successful high-wing Blériot design as a basis, Nieuport greatly improved it. The wings had an aerodynamically advantageous taper, the fuselage was fully covered with fabric, and the pilot was seated deep inside the body. Nieuport's innovative ideas quickly found followers and imitators. Just a year later, at the Third International Air Exhibition held in Paris at the Grand Palais, it was noted, Blériot left the rear part of his fuselage open because he feared the side wind that might swing the tail. This view had been universally accepted until the appearance of the Nieuport. Now, uncovered machines are no longer seen. They are ugly and have great drag. Continuing to refine his designs, the successful inventor built several more aircraft powered by engines producing between 30 and 50 horsepower. To expand production, a small aircraft company was organized in Issy-les-Moulineaux. In March 1911, during the air competition in Mourmelon, the Nieuport Monoplane set a world speed record, 74 miles per hour. After that, records followed one after another, both with and without passengers over various distances. Between the 14th and 22nd of May 1911, an Aviation Week, as competitions of pilots and new flying machines were then called, was held in St. Petersburg. 8 airplanes of Russian and foreign manufacture participated. During those days, the Nieuport monoplane, very similar to a later model, appeared for the first time on Russian soil. The French pilot Chevalier set a speed record for Russia, covering the distance in 6 minutes and 5 seconds. At a speed of about 61 miles per hour. On the 1st of July 1911, at the Eastchurch Airfield on the Isle of Sheppey, at the mouth of the River Thames near London, the third international race for the Gordon Bennett Cup took place. This silver trophy had been established by the passionate sportsman and aviator Gordon Bennett, editor of the newspaper New York Herald, to honor pilots achieving the highest speeds. According to the competition rules, the cup was awarded to the Aero Club of the winner's country, which also received a cash prize of £12,500. The first aviation competitions took place in the French city of Reims in the summer of 1909. In the 12.4-mile race, the American Glenn Curtiss claimed victory, covering the distance in 15 minutes and 50 seconds. Afterward, the next competitions were moved to America. There, the best result on a 62-mile route was shown by the Englishman Graham White, 1 hour, 1 minute, and less than a second. Now, in July of 1911, the Cup was returning to France once again. The fastest pilot was Weymouth, flying a Nieuport monoplane. In total, England presented 3 aircraft designed by Édouard Nieuport, and all of them became the unquestioned favorites of the competition. Weymouth flew the new Nieuport with a 90-horsepower rotary Gnome engine and reached a speed of 78 miles per hour. The designer himself flew a model with a less powerful engine and achieved 75 miles per hour. From the 5th to the 17th of September that same year, large military maneuvers of 2 Army Corps took place in France, near the German border, involving 46 aircraft. Among them were 5 Nieuports, which performed quite satisfactorily. However, for Edward Nieuport himself, these exercises ended tragically. Being a reservist, he took part in them personally, piloting his own aircraft. On the 15th of September, near the town of Charny, Nieuport went on a reconnaissance mission against a mock enemy in extremely unfavorable weather conditions. A strong gust of wind overturned the machine. The aircraft fell from a height of several dozen meters to the ground. The next day, the outstanding aircraft designer passed away. After the maneuvers concluded, a military aircraft competition was held in Reims. Participants had to complete 5 different trials: landing on plowed soil, landing in an oat field, landing in a field sown with alfalfa, a speed flight over a distance of 37 miles, a test of altitude and load capacity. The aircraft had to climb to 1,640 feet within 15 minutes while carrying a load of 660 pounds. In addition to these trials, it was considered very important for an aircraft to be capable of quick disassembly after landing, transportation by automobile over a considerable distance, and subsequent reassembly followed by takeoff. The design of the Nieuport monoplane, compared to other aircraft, especially biplanes, proved to be the most suitable for such an original challenge. The decisive test, in which 9 aircraft from different designers took part, took place on the 1st of November. In the Reims to Amiens flight, covering 186 miles, the first place went to pilot Weymann, flying a Nieuport with a 100-horsepower Gnome engine. He completed the route in 2 hours and 35 minutes, maintaining an average speed of 73 miles per hour. These events were well known in Russia. The aviation press covered them in detail under the section News from Paris. It is no surprise that Nieuport aircraft appeared to be the most attractive choice for use in Russian aviation. In the summer of 1912, several examples of Nieuport monoplanes were already present within the territory of the Russian Empire. During this period, 2 flights took place along the Sevastopol to St. Petersburg route, which were justifiably considered outstanding aviation events of the year. The newspaper Novoye Vremya called them remarkable flights across all of Russia. The first flight in a Nieuport was completed by Lieutenant Dubowski between the 27th of May and the 7th of July. The long duration of the journey was caused by poor weather conditions along the route. In Moscow alone, he had to wait 2 weeks for clear skies. The second flight, also in a Nieuport, was carried out by Staff Captain Andreatti. On the 2nd of July, he took off from Sevastopol, flew past Odessa, and landed in St. Petersburg on the 12th of July. Thus, all the events that preceded the choice of a particular aircraft type for equipping the Russian Army's aviation forces turned out in favor of the Nieuport monoplane. In June 1912, the head of Russian aviation, Grand Duke Alexander Mikhailovich, initiated an important agreement. The main engineering directorate signed a contract with the French company Nieuport for the supply of a batch of monoplanes to Russia. The Air Fleet Department provided the funding, while representatives of the Russian military agent in France oversaw the execution of the order. To receive the first aircraft and learn to fly them, the Aviation Department of the St. Petersburg Aeronautical School sent 2 officers to France in mid-July 1912, Alexander Kovanko and Sergei Modrach. After they mastered flying the planes, Kovanko and Modrach received pilot certificates from the French Aero Club. They personally tested each accepted aircraft and prepared them for shipment to their homeland in August 1912. By the end of their assignment, the acceptance pilots had thoroughly studied how Nieuport aircraft were manufactured, assembled, and fine-tuned. Initially, the aircraft did not arrive in St. Petersburg, but instead went to the flight school in Warsaw at the Mokotów airfield. The reason was simple: an early and cold winter had already reached St. Petersburg. Therefore, the graduation of the aeronautical school officers, which included training on the new type of aircraft, was moved to Warsaw. There, a thin snow cover allowed flights on wheels almost year-round. Incidentally, starting the following winter, Russian aviation became the first in the world to actively use ski landing gear in winter. The Nieuport planes were equipped with skis designed by Lobanov. In January 1913, 12 of the most skilled pilots, under the supervision of Kovanko and Modrach, mastered piloting the aircraft. Afterward, they were assigned as detachment commanders. These were staff captains Bogdanovsky, Karachayev, and Prusis, and lieutenants Denisov, Yefimov, Ivkov, Malishev, Nesterov, Stoyakin, Ushakov, and Firsov. It is worth noting that learning to fly the Nieuport was quite challenging even for pilots who already had flight experience. Unlike all other aircraft where the pedals controlled turning, on the Nieuport the pedals controlled the roll, the tilting of the aircraft to the side. This was achieved by warping the wings. Turns and altitude control, on the other hand, were handled by the control stick. Thus, pilots who transitioned to the Nieuport had to forget all their previous habits and essentially learn to fly from the beginning. Lieutenant Nesterov described his first flights as follows. After flying on the training aircraft for ground practice, I was allowed to fly the actual Nieuport. Colonel Ulyanin and many officers were present. I took off after Ushakov and another pilot. Ushakov was nervous and made a dangerous takeoff, which frightened us all greatly, but then he recovered and finished successfully. Then I flew. Although I didn't feel the same as on the Farman, I performed the same maneuvers as on the Farman, using my control technique with wide banking and calmly gliding down. Later, after 2 years of flying the Nieuport, Nesterov became fully accustomed to handling it. In 1914, he had to retrain on the more modern Moran, which used a classical control system. When he tried to master the new aircraft immediately, it did not go well. Nesterov himself noted that retraining was very difficult, and he had to start with long taxiing runs across the airfield. Eventually, the unconventional control system of the Nieuport caused significant trouble for Russian aviation. In 1916, while investigating the causes of numerous crashes and accidents, Colonel Demchenko wrote to the chief of the Russian General Staff. Even in 1912, recognizing the Nieuport as suitable for army service was a dreadful mistake. One that led to very sad consequences, in particular the difficult situation at the beginning of the war. The choice of another aircraft seemed highly unlikely. At the time it was selected to equip Russian aviation units, the Nieuport was perhaps the most refined and well-developed airplane in terms of both design and maintenance. Its flight characteristics also raised no complaints, and its unusual control system surprised no one. After all, in 1912, aviation had not yet moved beyond the experimental stage, and the standard control schemes were still being developed through trial and error. In any case, the Nieuport airplanes were initially evaluated quite positively, and along with the Farman biplanes, they became the main products of Russian aircraft factories for almost 2 years. From the autumn of 1912 to April 1914, the production of these aircraft was as follows. The Russo-Baltic plant in Riga, 38 units. Shetinin plant in St. Petersburg, 57 units. Dux plant in Moscow, 55 units in total, 150 airplanes. In the following years, these monoplanes were also produced by the Lebedev, Anatra, and Shetinin factories. Altogether, according to the aviation historian Vadim Borisovich Shavrov, no fewer than 300 such airplanes were built in Russia. The arrival of the Nieuport in Russia coincided with the creation of the military aviation branch and the formation of the first 6 aviation detachments. However, the effort begun in 1912 due to organizational difficulties and the long winter came to full fruition only by the middle of the next year. That summer, the newly formed detachments were mastering new technology, methods of employment, and ways of cooperation with ground forces. For instance, the 11th Aviation Detachment, attached to the 7th Aeronautical Company, not only conducted flight training in the summer of 1913, but also tested methods for adjusting artillery fire. From the 1st to the 29th of July, artillery exercises were held at the Darnitsa training range, located 9 miles from Kyiv. The 11th Aviation Detachment, commanded by Pyotr Nikolaevich Nesterov, had at that time 3 Nieuports and 1 Farman. Since aircraft were not yet equipped with radio stations, communication between pilots and artillerymen was carried out through written reports. After performing a salvo and observing the explosions, the air observer would drop a note from the aircraft into the artillery battery's position. Based on the received recommendations, the artillery commander made the necessary corrections to his fire. During the summer of 1913, a number of field exercises of the Russian Army were conducted with the participation of Nieuports, and several cross-country flights were carried out. However, the most famous event was pilot Nesterov's performance of the Loop-the-Loop on August 27th. The incident was confirmed by a report compiled on the spot. On the 27th of August, 1913, at 6 hours and 10 minutes in the evening, Lieutenant Nesterov, having climbed in a Nieuport to an altitude of 3,280 feet, stopped the engine, and began gliding almost vertically downward. At an altitude of 1,970 to 2,625 feet above the ground, the pilot restarted the engine, leveled the airplane with the elevator, pointed its nose upward, inverted onto its back, and again bringing it into a vertical nose-down position, thereby closed the curve in a vertical plane. He then stopped the engine and landed by a normal gliding descent on the same starting field of the Syrets military airfield. The entire turn in the vertical plane was performed smoothly without brakes in the course of 6 to 8 seconds. Commander of the 3rd Aviation Company, Lieutenant Colonel Vereskov. Sports Commissioner of the Imperial Russian Aero Club at the Kiev Aeronautical Society. Military pilot Lieutenant Yesipov. Pyotr Nikolaevich Nesterov himself described the event in a newspaper article, Petersburg Gazette, issues of the 4th and 5th of September 1913. Having recently received a Nieuport machine assembled at the Dux factory and having flown it for no more than 10 hours, I finally decided to fulfill my dream. I warned no one about my experiment, although everyone knew what I intended to do. On the evening of August 27th or September 9th by the new style, Nesterov strapped himself to the seat and climbed to an altitude of 3,280 feet. From this height, he decided to begin his maneuver. Before starting, he glanced one last time at the altimeter, a simple device resembling a clock. It crossed his mind that if something went wrong and he ended up upside down, the small instrument might fall out of his jacket pocket. But Nesterov decided to risk it for the sake of greater authenticity. In truth, that was all he risked. Government property worth 13 rubles and 50 kopecks. The hardest part was simply making the decision. But as soon as he shut off the fuel supply to enter a gliding flight, he immediately felt lighter and focused on his task. Nesterov tilted the airplane almost vertically and began to glide, watching the altitude closely. He wanted to maintain a reserve in case of failure. At around 1,970 feet, he began to level the aircraft. As it passed through the horizon, Nesterov reopened the fuel supply. The engine responded beautifully. The airplane soared skyward and began to roll onto its back. Nesterov's left hand remained on the fuel lever, controlling the engine's operation precisely. Though he longed to rest his hand on the fuselage as during an ordinary descent, he resisted. For a moment, it seemed to him that he hadn't seen the ground for too long, but by pulling the control stick just a little more, he saw the earth again. He shut off the fuel once more and, leveling the aircraft, glided toward the hangars. During that entire 10-second flight, he felt the same as in a regular horizontal flight with a bank of 70 to 80 degrees. He could sense the airplane's turn with his body, much like how one feels a train car turning while lying inside it. The dead loop gained particular fame because of disputes over who performed it first. Who was first, the Russian Nesterov or the Frenchman Pégoud? It is known that in the summer of 1913, Pégoud executed in the air a figure shaped like the Latin letter S. Nesterov, on the other hand, completed a closed vertical loop according to his own concept of aerobatic possibilities. He is credited with the famous phrase, "In the air, there is support everywhere." After Nesterov performed his loop, the French aviator Louis Blériot prepared one of his monoplanes specially reinforced. On September 21st, 12 days after Nesterov, aviator Pégoud executed his own dead loop. Interestingly, the Russian aviation authorities, fearing for the pilots' lives, categorically forbade anyone from repeating Nesterov's feat. However, within a year, the ban was deemed unnecessary, and many Russian pilots mastered the Nesterov loop. According to the memorandum of the chief of the main military technical directorate dated October 3, 1914, at the beginning of the war, the aviation service included 31 corps detachments and 8 fortress detachments. They had 133 airplanes and 91 monoplanes. Apparently, the preference for monoplanes led to all of them being listed under a single name in this document. At that time, there were aircraft of various models. In reality, the total number of planes was slightly smaller. Out of 213 aircraft sent to the front, 98 were of the same type. A characteristic feature of the early period of military operations in Russia was the noticeable wear of available aircraft, the shortage of spare parts and engines, and the lack of means for transporting aircraft in disassembled form. Transport by automobile was considered desirable but unlikely due to the scarcity of vehicles. Therefore, operations followed pre-war instructions developed back in 1913. For towing an airplane, the wings, the stabilizer with the elevators, and the rudder were removed. The wings were then fastened along the fuselage with their broader part forward and their tips toward the tail using 2 frames. The stabilizer with elevators was placed on top of the wings, and the rudder was laid inside the fuselage in the pilot's seat. The propeller was not removed. It was simply positioned vertically. The lower blade was wrapped in cloth and tied to the chassis with a rope. Where the wings touched the fuselage, hay, rags, or felt were placed to protect the fabric of the wings, fuselage, and stabilizer from abrasion. The tail section of the aircraft was placed on a cart, on a cushion made of hay or something soft. The rear part of the landing gear was tied with both ends of a rope to the back edges of the cart. A man had to be on the cart to hold the tail of the aircraft. For long-distance transport, to preserve the tires, they were wrapped with rags and secured with thin rope. These monoplanes were first used in combat on the 1st of August 1914 during the East Prussian operation. There, in the sector of General Samsonov's advancing army, 2 aviation groups were operating, which together had 11 aircraft. In Galicia, one of the Army's aviation units included 9 such monoplanes from 2 aviation detachments. Another army had 15 of these aircraft in 3 aviation detachments. The main task of these monoplanes at the front was reconnaissance. When the weather permitted, the crews, risking their lives, flew deep into enemy territory, delivering information about the movements and concentrations of enemy forces. However, the active use of aviation led to the loss of almost half of all aircraft during the first 2 months of the war. The main reason was the already mentioned wear and tear of the equipment, which caused frequent breakdowns and failures in flight. It should be understood that aircraft of that era were not durable at all. A plane that had served for a year or a year and a half was considered old and worn out. Several monoplanes were shot down by anti-aircraft fire. As everywhere else, crashes occurred due to piloting errors. In addition, there were known cases of friendly fire caused by misunderstandings and landings on enemy territory due to loss of orientation. As a result of all this, by the next summer season, when the weather once again allowed flights, a significant portion of these monoplanes had been lost. In 1915, aircraft factories mostly switched to producing other, newer types of airplanes. Deliveries of these monoplanes to the front during that period were minimal. These aircraft had very little impact on the course of hostilities since they were used during the first stage of the war, when the tactics of aviation and methods of cooperation with ground forces were still being developed. At that time, aircraft had no weapons except for the crew's Mauser pistols or carbines. Nevertheless, on certain planes, thanks to the presence of a second crew member, attempts were made to install machine guns for firing at the rear hemisphere. One aircraft built at one of the factories had the wings, tail section of the fuselage, and landing gear taken from this monoplane. Among the first monoplanes of this design, 3 main types are usually distinguished. Different sources provide highly inconsistent data about their dimensions and engines, so it is quite difficult to systematize these often one-of-a-kind models. One researcher wrote about the existence of one of the earliest prototypes equipped with an engine of 18 horsepower. Unfortunately, no additional details about the use of this unique aircraft have yet been found. An aviation publication from 1911 states that during one of the air shows, a pilot named Chevalier flew a plane equipped with an engine of 30 horsepower. Later, such airplanes became among the first to be produced in small numbers. All these machines with low-power engines of 25 and 45 horsepower or 50 horsepower were classified under the general term training. The dimensions and weight characteristics of these aircraft varied. Their length ranged from 22 to 26 feet, wingspan from 26.7 to 32.2 or 37.7 feet, and wing area accordingly from 150.7 to 204.5 square feet. Detailed dimensions can be found in the document titled List of the Weights of Parts of the Nieuport Training Airplane, which was used at the Officer Aviation School in Sevastopol as early as 1913. The length of one wing was about 13 feet. Taking into account the width of the fuselage, the full wingspan reached 27.6 feet. The width of the wing at the fuselage was 7 feet. The total wing area equaled 155.5 square feet. The fuselage length reached 21.3 feet. The stabilizer span was 7.4 feet, and its maximum width without the elevator was 4.1 feet. In the same pilot's manual, the combat Nieuport was also described with the following specifications. The wingspan measured 16.4 feet, and taking the fuselage width into account, The full span reached 35.1 feet. The wing chord near the fuselage was 8.2 feet, tapering to 5.8 feet at the tips. The total wing area amounted to 230.3 square feet. The fuselage length, excluding the engine shaft with the propeller and the rudder, reached 22.4 feet. The stabilizer span measured 9.9 feet. These dimensions correspond to the French Nieuport of the fourth model. They completely match the drawings made by the Germans during the War of 1914 to 18. These drawings were created from a captured French aircraft known as the Nieuport Monoplane. Fragments of these blueprints were later published by a German aviation magazine as an appendix. The Moscow aircraft factory, Dux, began producing the French monoplane in 1912. The first examples received the name Dux monoplane and were exact copies of the French fourth model. At the same time, several modifications appeared, developed with the participation of the aircraft designer Mosk. One of them combined the lifting surfaces and landing gear of the Nieuport with a truss fuselage, stabilizer, and crew cockpit taken from another aircraft. In the rear section of this hybrid design, a rotary engine with a pusher propeller was installed. This composite aircraft was submitted to the military airplane competition, but due to poor flight characteristics, it was not accepted. An interesting feature of this machine was the installation of a Maxim machine gun in the front section of the crew cockpit. It is worth noting that the vast majority of military aircraft at that time were still unarmed. The next modification largely repeated the fourth model, but featured an original power plant and ailerons on the wings. The Salmson engine, rated at 80 horsepower, was installed in the center of the fuselage behind the pilot's seat. Through a chain transmission, the rotation was transferred to two propellers mounted at the leading edge of the wings. The aircraft, built in 1913, underwent testing but proved too complex and unreliable due to issues with its power plant. Subsequently, the Dux factory abandoned these original solutions and, up until 1916, continued to produce standard fourth models differing only in engines and dimensions. Most often, they used rotary Gnome engines rated at 70, 80, or 100 horsepower. The most common variant, equipped with a 70 horsepower engine, had a wingspan of 39.4 feet, a length of 25.6 feet, and a wing area of 242.2 square feet. Military pilot Lieutenant Viktor Vladimirovich Dubovsky improved the aircraft by refining the engine cowling. To enhance visibility, the sides of the fuselage were made of glass. In 1913, this Nieuport with a 70 horsepower Gnome engine flew successfully. Sport pilot Vladimir Vladimirovich Slyusarenko in 1915 installed a standard control system and ailerons on one of the aircraft. The plane flew well, and there were plans to begin serial production. Military pilot staff Captain Vasily Mikhailovich Olkovsky, who commanded the 5th Aviation Park in Bryansk, equipped a standard Nieuport with ailerons and normal controls in 1916. This demonstrates how inconvenient the original Nieuport control system was if so many enthusiasts sought to replace it. Military pilot Pyotr Nikolaevich Nesterov, together with mechanic Georgy Mikhailovich Nelidov, completely redesigned the tail section of the Nieuport. According to their own project, they shortened the fuselage by approximately 2.3 feet. Instead of the standard stabilizer and rudder, they installed enlarged elevators. These control surfaces featured aerodynamic balancing and could move independently, performing the functions of both vertical and horizontal control. In the spring of 1914, several flights were performed on this modified aircraft. It was planned to continue the development of this invention at the Dux factory. However, in the summer of 1914, the war began, and soon after, Pyotr Nikolaevich Nesterov was killed. Thus, this fascinating project was never completed. The Nieuport is a wire-braced monoplane designed for a crew of 2. The fuselage is wooden, built on a truss framework reinforced with internal bracing wires. The covering is made of fabric, while the upper front section and the engine area are sheathed in aluminum panels. A distinctive feature of the Nieuport's fuselage compared to most aircraft of that era is its height, or one could say its volume. Thanks to this, the pilot sat deep inside the cockpit. At the top center of the fuselage, a 4-sided pyramid structure was installed to anchor the bracing wires. The wing has 2 spars and is covered with fabric. The required rigidity is achieved with the help of steel wire bracing. There are no ailerons. Roll control is achieved by altering the tension of the rear bracing wires, which twists the trailing edge of the wing. The tail assembly is made of flat profile steel tubes and covered with fabric. The stabilizer is supported by struts, and the vertical fin is fully movable. The cockpit is located between the spars, with the seats arranged one behind the other. The controls are single. The seats are placed above a fuel tank with a capacity of 45 gallons, and the second crew member, the navigator, sat on it astride in a cavalry-like position. The landing gear is shaped like an inverted pyramid with a central extended beam. The end of this beam acts as a tail skid, while a small ski is mounted at the nose to prevent nosing over. Shock absorption is provided by a transverse spring, and the wheels are spoked. The power plant is a rotary Gnome engine. Aircraft equipped with lower power engines had a shorter nose section. For maintenance convenience, the top part of the engine cowling could be opened. A characteristic feature of the Nieuport, and indeed of all early Nieuport models, was the front engine mount, a rectangular structural plate fitted with a ball bearing in which the crankcase nose rotated. Rotary radial engines gained significant popularity during the early years of aviation for several reasons. In a rotary engine, the cylinders rotate around the axis of the crankshaft, while the pistons move around the axis of the crank pin. Thus, during operation, the crankshaft remains stationary, and the propeller rotates together with the cylinders and the engine crankcase. Among the advantages of rotary engines were their light weight, the ability to cool cylinders efficiently even at low speeds, and the achievement of smooth rotation at low revolutions without the need for a flywheel. The disadvantages included high fuel consumption and, especially, excessive oil usage, as the oil was simply splattered out through the exhaust valves of the cylinders during operation. This caused the legendary messiness of aircraft equipped with rotary engines. After each flight, the entire underside of the fuselage and wings would be drenched in streaks of half-burned oil, which mechanics had to scrape off. Castor oil that soaked into the fabric was difficult to wash away, so the planes almost always bore greasy stains, clearly visible in photographs. In addition, due to the strong gyroscopic moment caused by the heavy rotating engine components, the aircraft was more difficult to control. The Gnome engine became the forefather of all subsequent rotary aircraft engines. It was produced with different numbers of cylinders, from 5 to 14, with power outputs ranging from 30 to 120 horsepower. The most popular version, produced between 1911 and 1914, was the 50-horsepower Gnome. This 7-cylinder engine weighed 168 pounds without fuel or oil. It operated at 1,200 revolutions per minute. A unique feature of this engine was that the intake valves were located directly in the pistons. Each cylinder had only one exhaust valve, which is why in France this engine was called monosoupape, meaning single valve. Later, this system was considered less effective and was never used again. The engine's casing consisted of a main section to which the cylinders were attached and two covers, a front and a rear one. The front cover enclosed the valve timing mechanism, while the rear served as a support for the main bearing. The cylinders were machined from nickel steel, and the pistons were made of cast iron. Lubrication was provided by an oil pump, which delivered oil into the hollow shaft and into the main bearing. Fuel entered through a device located at the end of the hollow shaft. Some publications referred to it as a carburetor, but in reality, it was an injector or spray nozzle. Unlike a conventional carburetor, it did not allow the engine's power to be controlled with a throttle valve. Therefore, the pilot managed the engine differently, by shutting off the fuel supply with a valve or by switching the magneto contacts on and off.